Welcome to Physics and Chemistry Made Easy. In today's class, we will see something about human eye and colorful world. In this human eye and colorful world, we come across the first topic called as least distance of distinct vision. This we also called as LDDV. Least distance of distinct vision means the least distance at which we can see an object very clearly. Now this LDDV increases with the increase in the age. So for 0 to 10 years children, the LDDV is around 7 centimeters to 8 centimeters. For the middle-aged people, LDDV is 25 centimeter, and for the old age people, LDDV is 1 meter to 2 meter. Now what do you notice here? Age is directly proportional to LDDV. That means as the age is increasing, LDDV is also increasing. Now we will see what actually it is. Let us take a rubber band, a fresh rubber band purchased from a shop, a rubber band with certain radius. Say we have given this rubber band to a student and we have asked him to stretch it for a whole day. So this is, suppose that this is the radius of this rubber band, fresh rubber band. So we have asked him, he has to put 2 fingers inside it and just stretch for the whole day. See, this activity started from 6 a.m. and ended up with 6 p.m. So for about 12 hours, he is asked to stretch the rubber band. Now you tell me, at the end of the day, will the radius be same? No, because it is a rubber band, it has lost its elasticity. So it has not regained its original radius. It is not in a position to regain its original position. Why? Because for the whole day it was stretched. So this is compared with the ciliary muscles. In our eye. There are ciliary muscles in our eye. They are similar to the rubber band. What happens? For example, myself, I have used these ciliary muscles for a period of 53 years. So automatically my eye has lost the elasticity. My ciliary muscles have lost elasticity. So they are not in a position to come back to the original state. That means what happened? They have become weaker. So they lost a property called as accommodation. They have lost a property called accommodation. That means accommodation is the working principle of a ciliary muscles. That means they adjust the focal length. Accommodation means what? Adjusting the focal length. Okay, now human eye. Let us draw human eye and see the parts and all that. Now let's speak about human eye. Let me draw the structure of human eye. This is called cornea. Outer part of the eye is called cornea. Now human eye contains a convex lens. The working style of a convex lens is to converge a light. So all the light that is falling along with the image, okay, along with this get converged on retina. So this part is called retina. Right. A lens consists of a small opening called as pupil. The size of the pupil, increasing or decreasing of the pupil size, is done by iris. So this is iris. When we happen to play outside in the ground, large quantity of light is available. Therefore, what happens is iris will decrease the size of pupil so that more intensity of light does not enter into the eye and spoil retina. Therefore, size of the pupil is decreased by iris. Again, all of a sudden when you enter into a room, the amount of light that is present in the room may not create an image on the retina. Therefore, what happens for a period of time, we find dim and dark. In a fraction of seconds, what happens? Iris again increases the size of pupil because the intensity of light is not enough over there. So it takes time in increasing the size of pupil. So the size of pupil, increasing or decreasing the size of pupil, is done by iris. The next what you find is ciliary muscles, as I was telling you just now. Right. Ciliary muscles, what do they do? As I told you in the beginning, they do the work of accommodation. These ones, these are ciliary muscles. They do the work of accommodation. Accommodation in the sense what? They try to make image fall on retina. So as age increases, these ciliary muscles, they also lose their elasticity. So sometimes the image may not fall on the retina, or else sometimes image may fall behind the retina. All this takes place because weakening of these ciliary muscles. That's what I was telling you about rubber band. Now people with the age of 0 to 10 children, their ciliary muscles are very fresh. So they have got a lot of elastic power. So they even sleep on the floor and do their homework. Right? While writing, they put their eyes very close to the book also, nothing will happen because their ciliary muscles are fresh. Now, middle age means they have used ciliary muscles for a period of some 20-25 years. Therefore, what happens? Those ciliary muscles have lost their elasticity. So, LDTV have shifted to 25 from 7 to 8 centimeters. It has shifted to 25 centimeter. And a course of time, as we grow up, old age, then ciliary muscles, they lose their elastic power totally, and LDT will shift to 1 meter to 2 meter. Now coming to the other one, that is all about ciliary muscles. Now this is called receptors. These are receptors. They are about 125 million receptors. 125 million receptors. They are again classified into two types, rods and cones. Rods identify the intensity of light. Cones identify the color. So you can remember this C, color. They identify color. Rods, they identify intensity of light. How much amount of light is entering into your eye. If it is more, they send the information to iris, and iris decreases the size of pupil and so on. Now the image that is falling on retina has a characteristic real and inverted. Image is real and inverted. This information is sent to brain through these receptors, and it is again made erect. Right? And the distance between this eye lens and retina in your eye is 2.5 centimeter. We call it as image distance. Okay, it is image is falling over here, image distance. And nothing but it is a focal length. It is a focal length of an eye. This is something about human eye. Now we will see how much accommodation can a human eye do. So therefore we come across 2 points. One is maximum focal length of an eye. The other one is what? minimum focal length of an eye, human eye. So since you are saying maximum focal length of the eye, going for the derivation is also very easy, but you have to keep in mind the name maximum. When you say maximum, as I told you previously in there also, u has got two values. One will be 25 and the other one will be infinity. So maximum means object distance is infinity, and v is, you are speaking about human eye, therefore it is 2.5. In the same manner, right, we will continue with minimum. Minimum u means it is, my minimum is minus 25, and since you are speaking of the eye only, therefore it is v is equal to 2.5 centimeter. Okay. Maximum focal length of an eye is 1 by f is equal to 1 by v. I, we are speaking of eye, so its length 1 by u. 1 by f is equal to, what is given 1 by v? V is equal to 2.5 plus 1 by u is 1 by infinity. 1 by infinity is equal to 0. Therefore, 1 by f is equal to 10 by 25. Then f is equal to, it is 25 by 10. Your answer is 2.5 centimeter. This is the maximum focal length of an eye. Now coming to minimum focal length of an eye, as I told you minimum, so it is 25 minus 20, minus is, u is always minus, so 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to, what is 1 by v? 1 by 2.5 plus 1 by 25. So 1 by f is equal to, it is 10 by 25 plus 1 by 25. Since denominator is same, so you add the numerators, 11 by 25, that's 1 by f. Therefore f is equal to 25 by 11, nothing but 2.27 centimeter. So the maximum focal length of an eye is 2.5 centimeter and the minimum focal length of an eye is 2.27 centimeter. This much is the accommodation done by ciliary muscles. Now this is up to maximum and minimum focal length of an eye. Now we will see eye defects. There are mainly three eye defects. First one is myopia. The next one will be hypermetropia, and the last one will be presbyopia. Myopia means a person suffering from myopia. He is also called as short. This sight is also called as short-sightedness. It can also be called as nearsightedness also. These are other names, nearsightedness. A person suffering from myopia can see object which is near, can see. And cannot see object which is far. Can't see object which is far. Interesting thing. Myopia, a short name. Other one is hypermetropia, a long name. So short name, short sight, nearsightedness. So he can see object which is near only. He can see object which is near. He cannot see object which is far. So the maximum focal length of eye, is less than 2.5. Very important point, key point it is. Maximum focal length of eye is less than 2.5. So therefore what arises here is far point. Now you can simply remember it. Myopia, short sight, short, but the point arises is far point. So the maximum, far point, far maximum, easy to remember, okay? Maximum focal length of eye is less than 2.5. Far point. Far point means what? Point of maximum distance for which eye lens can form image on retina. That is the definition of far point, point of maximum. So you are speaking of far, so you treat this as maximum. The remaining it is same. Point of maximum distance for which eye lens can form image on retina. That is the definition of far point. Now coming to the derivation, u is equal to, as I already told you, far point, so it is infinity, and u is always negative, so minus infinity. V is equal to, it's a defect, therefore it is minus d. 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by, what is v? Minus capital D plus u is infinity plus infinity. 1 by infinity is equal to 0. Therefore, f is equal to minus d. Now you all know focal length is negative for a concave mirror. Convex mirror focal length is positive. Therefore this defect is corrected using a biconcave lens. Biconcave lens. Why biconcave? Because focal length you got it as negative. Negative focal length is for biconcave lens. This is something about myopia. Now I will show you the diagram and the defect and correction part of myopia. So for this I can advise you, you better use 4 sets of diagram. Now let me show you myopia diagram formations. Myopia. So eyeball over here, second one, third diagram, fourth diagram. It will be good if you can really draw 4 sets of diagram. Right. So I am explaining you myopia. So this my point will be myopia, M point. And this will be LDTV. This is a lens here, convex lens. So this is eyeball, therefore a little bit cornea also I will show you cornea. Right. So what happened myopia? He can see object which is at M. Myopia, he can see object which is at M. So here, this is retina. So you have to show rays exactly touching, coinciding or meeting at retina. Now what does this prove? He doesn't have any problem to see an object which is at a point M. Now what happens? He can see object which is near. So you have to take a point which is close to the eyeball, and you have to connect it again. You have to draw up to retina. He can see object which is from M. He can see object which is near. Myopia, first patient can see object which is near. He cannot see object which is far. So third diagram should be the defect part of the diagram. He cannot see object which is far. So what happens? Yes. Instead of falling on retina, image is falling before retina. Maybe 2 things. Focal length might have increased, or else eyeball size might have increased. Okay, this is the reason it's happening. Other thing, that he is not able to see object which is far. The best thing is what, third and fourth diagram on this side, these two should be same. Third and fourth diagram should be same. Now what happened? You correct his eyesight. It will fall on retina. But what happens? When does this happen? We have just now seen that f is equal to minus d. That means a biconcave lens is given as correction. Biconcave lens. What does a concave lens do? Yeah, what does a concave lens do? It diverges the light. What does a convex lens do? Converges the light or image. Now what is happening? If you converge it, still it will converge here. Therefore, this should be pushed back. So the best one is concave. In this way also you can understand. Other one is through derivation also you got it as negative. This is understood. This is supposed to be pushed back. This can only converge. So it is not a suitable lens. Then this should be sent back as diverging lens is a perfect lens. Therefore, you need to add a diverging lens here, concave. Then you have to draw a line, dotted line to M, indicating that you have given a perfect lens to correct the defect. This is all about myopia. So in this way, if in the exam if you are getting doubt, you can even identify like this. Suppose you put your hand in the diagram, you will be in the page, on the page you will be drawing this much only. Now I am showing you like this. So he can see object which is at M. So if you can push it towards left side, why am I pushing my both fingers left side? It is because he cannot see object which is far. So I need to go towards left. So if you do like this, automatically your right hand is coming forward. That means it has to come here. This is how you show defect part. Thank you. Now we will see next hypermetropia. Second defect is hypermetropia. Farsightedness. Can see object which is far. Okay, farsightedness. Long-sightedness. Long sight also we call it as long-sightedness. Person suffering from myopia, he cannot see far object, he can see near object. Now our topic is what? Hypermetropia. He can see object which is far. Hypermetropia. He can see object which is far. He cannot see object which is near. So can see object which is far. He can't see object which is near. Therefore, what point arises here? Near point. As I was telling you, long sight, far sight, long sight, big name hypermetropia. Point is near point. In myopia, short name, short sight, nearsightedness, the point was far point. So near point, as I was just now telling you the definition, point of minimum distance for which eye lens form an image on retina. That is the definition. I have written it in short form. Now let us go for the derivation. We are supposed to get what now? Focal length. If you get it as negative, that will be a concave one. If you get the focal length positive, then that will be a convex one. We will try and see. So U is equal to near point, so it's minus 25 centimeter, and V, since it is a defect, minus D. 1 by F is equal to 1 by V minus 1 by U. 1 by F is equal to 1 by V is how much? It is minus small d plus 1 by 25. 1 by F is equal to LCM is 25D. So this is negative and this is positive. D goes 25 times. So it is minus into minus is plus. D into 25 is 25D plus 25 into D. 25 into D is equal to 25D. Plus into plus is plus. 25 into D is 25D. Therefore, reciprocal of this is F is equal to 25D by, since it is positive one, we write this side, that's all. We don't interchange anything, just shift the places. So it is 25D by D minus 25. If D is greater than 25, then this defect is rectified or corrected, okay, rectified by a biconvex lens. Yeah, you didn't get it negative, so positive in the sense biconvex lens. Biconvex lens is given as correction. So once again I tell you near point. Some students get confused with this one. Near point, u is equal to minus 25 and your v is minus d since it is defect. So when I go on 1 by f is equal to 1 by v minus 1 by u, 1 by f is equal to 1 by d is minus d plus, because minus into minus is plus 1 by 25. My LCM is 25d, so minus into minus is plus, d into 25 is 25d, plus into plus is also plus, therefore 25 into d is 25d. So f is equal to reciprocal, I got 25d by d minus 25, and if d is greater than 25, then this defect should be corrected with biconvex lens. Now I show you the diagrams. And one more point I forgot to tell you is minimum focal length of eye is greater than 2.27. If minimum focal length of an eye is greater than 2.27. This is another way questions are asked in CC. Let me tell you the question. Minimum focal length of an eye is greater than 2.27. What type of defect it is? Explain the defect with a suitable example, diagram, like that questions will be given. What was it for myopia? For myopia it was maximum, because the point was far point. So maximum focal length of eye is less than 2.5. It was for myopia. Since it is hypermetropia, this is hypermetropia minimum, because the point is near point. So minimum focal length of an eye is greater than 2.27. Logic, it is minimum, it's greater, and this is also minimum. When it is in myopia, this point was maximum and it was less than, and this point was again 2.5. Right. Now we will see the diagram part of the hypermetropia. After this, I will give you a question, information skill question, which is very important for exams. Now we will draw the diagrams of hypermetropia. Four sets of diagram. Convex part of the eye. Eye has got a convex lens. Then we draw cornea. Just to say that it is an eyeball. This is retina point. So since hypermetropia, we take it as H. In myopia, we took as M. LDDV, so it's H. Hypermetropia. Right, this is L. So a person suffering from hypermetropia, he can see object which is far. He cannot see object which is near. So for myopia, we have drawn lines like this, isn't it? This is similar to hypermetropia also. It is similar to myopia. Yes, exactly. He can see object from H. In myopia, he was able to see object from M. Hypermetropia patient can see object which is far. So you have to draw like this. In myopia, what did we do? We had drawn from here and said that he can see object which is near. Here he can see object which is far because he is hypermetropia. He cannot see object which is what? Near. Near means you have to take like this. What happens now? These rays converge at the back of retina. Somewhere at the back of retina. Maybe eyeball might have decreased its size right? And along with that focal length also might have decreased. So it is like this. He cannot see object which is near. Image is falling beyond its retina. Now, as I told you just now, let us think about two lenses again. Convex lens can converges. It's a working style of a convex, and concave, the working style of a concave is to diverge. Now see, image is somewhere beyond retina. That means it has to fall on retina. What we are supposed to do, we have to pull it back. That is done only by convex, because convex can converge. Therefore, the right lens here is convex. So light rays has to converge to retina. Now let me draw the same. I told you third one and fourth diagram should be same. Only thing what to do, you have to correct the side. Rays has to fall on eye retina, because you have already used a convex lens, converging lens. From here you have to draw dotted lines to H. Convex lens. Just now in the derivation also we got your D is greater than 25. So if D is greater than 25, we are supposed to use a convex lens. Right. This is all about hypermetropia. Now, information skill question based on this. And the next defect is presbyopia. This is seen at old age due to weakening of ciliary muscles. Ciliary muscles means what? Ciliary muscles can't perform accommodation. Accommodation means what? Adjusting the focal length and making the rays fall on eye retina, because they are used for a long period of time, these ciliary muscles. Remember, I was telling you something about rubber band, so they lost their elasticity. Now, this defect is corrected by bifocal lens. Now, you should understand bifocal lens. It's like this. Which lens you will find where? See, when we see a far object, we generally see it from here, this point. Generally, we see a far object from this point. If you cannot see an object which is far, we call it as myopia. So for myopia, what is the lens we gave on the top? Concave. So we gave them concave. So concave will be here, concave lens will be here. Because myopia patient can see object which is near, he cannot see object which is far. Far object generally we see from here, therefore the correction is concave. Now for hypermetropia, we can see object which is far, we cannot see object which is near. So the correction was by convex, therefore you find convex here. Because to see object which is near, generally we use this part. And suppose it should be corrected, then it is corrected with the biconvex lens. So you can even remember like this, no? Kvex. It will be easy for the students to remember this one. This part is cave and this part is vex. So join together. You can remember it, not to write in the exam, just to remember kvex. So this part, upper part is cave and the lower part is vex. This is something about presbyopia. It occurs as old age due to the weakening of ciliary muscles. Ciliary muscles cannot perform accommodation. That means adjusting the focal length. Therefore, bifocal lens is given, and on the top it will be concave to correct long distance sight, and down it will be convex to correct sight which is very near the one. Information skill question in this lesson is persons A, B, C, D, E. Okay, 5 persons over here he has given. What is the thing with first person? Maximum focal length of an eye is less than 2.5 centimeter. B is cannot see near objects clearly. C, minimum focal length of eye lens is greater than 2.25. Then what is this one? Loss of ability of accommodation. Loss of ability of accommodation. And the E is how much? The limits of the focal length of an eye lens are from 2.5 centimeter to 2.27 centimeter. This is what given. So there are about 5 persons having some ability, defect ability. So we have to identify with these 4 questions. The first question is, yes, information skill question on this lesson is, here he has given 5 persons. The A, B, C, D, E are the persons. The first person's defect is maximum focal length of eye is less than 2.5. The second one is cannot see near objects clearly. C, minimum focal length of eye lens is greater than 2.27. The next one is what? Loss of ability of accommodation. E is the limit of focal length of a eye lens are from 2.5 centimeter to 2.27. Now let us go into the questions. What is the first question? What is the defect of vision in D? So D, what is the D suffering from? So what is the defect of vision in D? Is D suffering from? So tell me, loss of ability of accommodation. Therefore, what is the problem he is suffering with? He is suffering from presbyopia. Because ciliary muscles are weakened. Ciliary muscles got weakened, okay? Completely they have become weak. Therefore, presbyopia occurs when ciliary muscles lose their ability of accommodation. And this happens at old age. He cannot see object which is near as well as object which is far. Right, next question. Whose defect of vision can be corrected by using biconcave lens? First of all, biconcave lens is given to whom? Concave is given to myopia person. Okay, person suffering from myopia. Biconcave is given. Myopia patient means what? He can see object which is near. He cannot see object which is far. He cannot see object which is far. So one thing, he can see myopia, can see near, can't see far. Now see, a person can see near, that is not given at all here. A person cannot see far, that is also not given here. Person cannot see near, cannot see is given, but can see is not given. Therefore now we have to identify the answer. In myopia, you remember, point is far point. So for far point, what was our definition? Do you remember? Maximum focal length of an eye is less than 2.5. So here maximum focal length of an eye is less than 2.5. So your answer is A. Answer for the second one is A. Because myopia, concave, and this is the definition. Far point, maximum focal length of an eye is less than 2.5. What did I say? You will get a point called maximum here and you will get the value maximum, but you will be saying that it is less. So your maximum 2.5, in between he has said less. So this is about myopia. So here myopia. Who is suffering with similar defect of vision as of B? First of all, B, here B, cannot see near object, means he can see object which is far, that's hypermetropia. Cannot see near, that means he can see far, hypermetropia. Now he is asking you, who else is having that problem? So, minimum focal length of an eye is greater than 2.27, minimum. Hypermetropia it is. How can you say? Because in hypermetropia the point arises is near point. Near point. See here, far point maximum 2.5. For near point, what is it? Minimum. Yes, minimum. And it is 2.5, so it is 2.27. Yes, this is the answer for C. Third answer, sorry, is C. Next, who among the above do not have any defect E? The limits of the eye, limits of the focal length of eye are 2.5 cm to 2 point. So proper accommodation is taking place here. This is the maximum value and this is minimum value. Therefore, it is true that who among the above do not have a defect of vision? It is E. A very important question for CC, information skill. Dispersion. Dispersion means one light ray splitting into 7 colors. So this is called dispersion. So now let us take a prism over here. So let us send a light ray, and light ray is supposed to go away like this. That is very important when you draw the diagram. You have to take this dotted line. So one light ray is incident ray. It bends because it happens to travel from rarer to denser. Therefore, it bends. This is a normal actually. So it bends towards normal. Bends like this. Again here, it is supposed to go away like this. That is very important. But what happens again? Since it is coming out, so you will find a normal over here. Since it is coming out from denser to rarer, so it will move away from normal. So you will find like this. Now let me rub on this, as I already showed you. So I need to rub, make it clear. So it's understood all this is normal and all that. You can get back to my video if you want to see the same thing again. It's understood. So what is actually happening here is very important. This light ray is supposed to go away like this, but it has deviated its path, and it has split into 7 colors. One light ray splitting into 7 colors. This is what we call dispersion. So it's violet over here. Violet, indigo, blue, green, yellow, orange and red. 7 colors. It splits into 7 colors. So the first one is violet, indigo, blue, green, yellow, orange and red. We have to mention this from the bottom. Why and all that now we will see. Now you tell me which color has deviated more. So this is supposed to be the line. So violet has deviated more from its path. Because one light ray was actually supposed to go like this. It has split into 7 colors. Still in this, violet has deviated maximum. The minimum deviation is done by red. Red has deviated less. So one thing you remember, deviation, violet has deviated more, red has deviated less. Whose wavelength is more? Red's wavelength is more. Red's wavelength is more. Why did I write like this? Red wavelength is more, but deviation is less. Therefore, this is inversely proportional. Wavelength is inversely proportional to deviation, or deviation is inversely proportional to wavelength. Deviation of violet is more. That is understood. Deviation of red is less. Everybody knows that red is selected as sign of danger signal, because its wavelength is more. This can be seen from a long distance. Now what is its character? What is happening here? Deviation is less. That means whichever is having deviation, less deviation, its wavelength is more. In the same manner, red deviation is less, its energy loss is also less. That is the reason it is able to reach a person which is very far. That's why we have selected it as a sign of danger. Its energy loss is less. Therefore, all the energy that is present with it, it is utilizing to travel for a long distance. So, deviation of red is less, energy loss is less, wavelength is more. Same manner, violet, when you speak about, deviation is more, energy loss is more, right, like that. Now when you speak about frequency, as everybody knows, frequency is inversely proportional to wavelength. Whose frequency is more? Violet's frequency is more. Violet's frequency is more. Number of cycles per second, violet frequency is more. Red frequency is less. Red frequency is less because its wavelength is more. Now we will see what do you mean by this. Suppose say you are taking red color. This is the wavelength of a red color. The distance between two successive crusts or the distance between two successive troughs we call it as wavelength. This is wavelength, and let us consider this for red. Red is for red. Now let us speak about violet over here. Violet. This is violet. So let us draw the same thing down. Let us draw the same thing down. You see how many peaks did you get in red color in one wavelength? The distance between two successive crusts is called wavelength, or the distance between two successive troughs is also called as wavelength. It is lambda wave. It's a wave, and this is the length. Now coming to violet, this is the wavelength. Distance between two successive crusts here. So wavelength is less here, wavelength is more. Number of peaks, you are taking certain time, the time taken from year to year, suppose it is 2 seconds. So in this 2 seconds, how many peaks did you get in red? Only 2 peaks you got. For the same duration, 2 seconds, how many peaks did you get? This is also called as peak. 2, third peak, and fourth peak. More number of peaks. More number of peaks means more number of vibrations, or more number of oscillations, or more number of cycles per second. Therefore your wavelength is less. Wavelength here for red is more wavelength, and for violet wavelength is less. Wavelength is more, number of peaks less. Number of peaks I called it as frequency. Number of peaks are less, means frequency is less, wavelength is more. Exactly, see, inversely proportional. Frequency here is less. Suppose I am pulling it down less, then wavelength is more, and it is true. Now wavelength of red is more, its deviation is less. Deviation should be less. Exactly, deviation is less. Now coming to violet, violet's deviation is more. So you mean to say violet's deviation is more. So energy loss is more. Its frequency also should be more. Yes, exactly. Now more number of peaks, its frequency is more. Frequency more, wavelength is less. Exactly, see, wavelength is less. This is something about dispersion. One light ray splitting into 7 colors. That is what you call dispersion of light. In the form of VIBGR, violet, indigo, blue, green, yellow, orange, and red. We are not supposed to write from the top. If you write from the top, violet will have less deviation, so everything will become wrong. More deviation is for violet.